Hello everyone, welcome to the Introduction to Computer Science, week number 4. I am sharing the week number 4 in Blackboard. As you can see, here's the list of objectives we want to accomplish and a list of items in the instructional material and the assignments that are being assigned for this week. And as it is indicated on the Blackboard left-hand side, all the assignments that are assigned this week is due on October 2nd. What I want to do is to go through the lesson plan, which is posted on for you, and then tell you what you need to do and what you need to know to do them. So if you click this and download, you should see this lesson plan. So the topic for this week is the functions in terms of programming, and in terms of the other material, you need to know about the gates and circuits. For the first assignment, which is from Zybook chapter 6, it's about functions. So if you go over to this out a little bit, over to Zybook chapter 6, this is the functions. And there's a lot of items in here that you can try around, but I think it'll be helpful for you to not only read them, but for me to actually do a demo on what it is. Okay. So coming back to the lesson plan, I will do a little demo using the programming assignment. So basically what I'm asking you to do is to write a function that will calculate this. Ask for the length and the width, and to figure out the area of a triangle. This can be done really easily and quickly in a normal way, but for you to understand and utilize functions, I want you to do it using a function. So let me demo for you, not the exact solution, but an example of what a function is and how it is being used. So if you open up any online programming compiler or whatever you want to do, this one happens to be Thony, and the code that I'm using is actually provided for you. Here are codes used for this week. So if you click this here, it should open up, and there's a lot of the examples that you can use. But anyway, so I copied the first item and then put it in here. So a function is a piece of program that you can write, and then you can call that function anywhere within other or rest of the program and use that portion of the program. So here the function is called my underscore function 1, and it is followed by def or definition, and then whatever code that you want this function to accomplish. And so this is how the function is created and identified, and you can have more than one line and do whatever you want to do. And this function just simply prints hello from a function. And then you can call this function by specifying the name of the function, which is my function 1. And so when your program executes from top to bottom, when it comes here, it would not be executed. Instead, it will be just noted on a table that it is a function and put it aside. And when it comes down here, line number 7, and when it actually calls that function, it'll pull up this portion and actually execute it, and then moves on. Here's another function number 2, defined that way, and it is expecting a variable to come through, a parameter, a name called first name or fname. And then it is going to print whatever is being called to this function plus the name of the space Johnson. So when this is executed, my function 2 here, you can pass a parameter. In this example, nothing is passed. It'll just simply go there and print this out. But when you call this function and you specify a variable, it is going to expect a variable or value. And you can say ml, and then when it calls here, it'll send this to this variable, and wherever this variable is used, as in this case over here, it'll perform this operation and then simply print, comes down to the next line and does the same thing. So we expect from here simply to print hello from a function, and from here 3 lines with these first names and Johnson. So if I run this program, you can see that it says hello from a function, which is this guy, and then it will just simply pass the first names and then prints the last one. So that's how you use or declare a function and use. And all you have to do for the assignment is to ask the user for the length and the width, and then spit out the answer for the rectangle. Let me put this on the side, and if I go back here, so that's pretty much what this guy is. And we know how to ask for things since we did that in the previous assignments. Now let me show you how to do the next item, and that is to design a circuit using gates. Gates, you can look at chapter 4 to understand what gates are and how they are used to create electronic circuits. But here is a basic website that you can go to understand what gates and what their functions are. But basically, this is a diagram that represents an electronic circuit that has 2 inputs, and this design is called AND gate. And the way it works is that you will, if A and a B are the inputs, like this here, it could be that it has a value of 0 and 0, or 0 and a 1, and a 1 and a 0, and a 1 and 1. In real world, this would be actual voltage, like 5 volts or 0 volts. So 0 would be 0 volts, 1 would be 5 volts. But in Boolean logic, in binary numbers, it's just represented as 0 and 1s. And this particular circuit called AND gate will produce an output of 1 when both A and B are 1, as you can see here. And all the other combination will be 0. So in other words, the A and B of value 1 will give an output of 1. And this one says either A or B can be 1 and you get a 1 out. So this will get a 1, that will get a 1, and this too will get a 1. And this one is a NOT gate, meaning whatever is coming in, it will be the opposite. So if a 0 volts is coming in, you're going to get a 5 volts. So 0, you're going to get a 1. 1 comes in and a 0 goes out. So stuff like that. So there are other kinds of gates that you can use called the logic gates to create a digital circuits. And basically what I want you to do is to create what's called a half adder and a full adder using a logic simulator. On the assignment here, I gave you a how to do the half an adder, full adder demo. And there is also, let's see here, I just posted up the instruction notes on how to do that, as well as a demo video, so you can take a look at them. But this notes here is basically on how to do these things, and you'll also see a video demo on how to do this. So take a look at that, and here is a link, 2 links on how to do those things. Here's a simulator, so if you click on that, you should get to here. Okay, so give it a try, and when you actually create the circuit, I'd like you to submit just a video link, not the actual video, and then you can publish it on YouTube or however you want to publish, and then share that with me, and that'd be fine. But let me spend a minute to talk about what a half adder and a full adder is. An adder is a electronic circuit that adds 2 numbers or digits, I should say, and it comes in 2 flavors. One is called half adder, and the other one is called full adder. Half adder circuit simply adds these 2 inputs. So these 2 input value can be either 0 or 1, right? So if when you add a 0, 0, you just get a sum of 0. If you add a 0 and a 1, you get a 1. 1 and a 0, you still get a 1. But if you add a 1 and a 1, that's a 2 in binary, right? So it'll be 1, 0. Or the sum of 0 with a carry of 1, right? And so let's see if I can show that to you. So here you go. So half adder is like the sum, these are just 1, but if both of them are 1 and 1, you get a sum of 0 and a carry of 1, right? So you can have two outputs. Now you could have a 3 inputs where these two are the inputs here, but then if you have a carry into in addition to this, then the output becomes a little bit more complex. So you'll have 3 inputs here, right? A, B, and a C in, and then this S will be the sum, and then it can have a carry out. So here, if all of the 3 inputs are 0, then you can the outputs are 0, right? 0 sum and 0 carry. If you have a 1 and a 1, like in half adder, you get and there's no carry in, then sum will be 0, but then carry over would be 1, right? But if you have all ones where the inputs are 1 and a 1 and a carry in is also 1, that's a 3, right? 3 in binary is 1, 1, or the sum of 1 and a carry of 1. So you can give that a try, and I hope that makes a little bit more sense. And these LEDs will also be lighting as you see my demo. Okay. All right. So hopefully that will give you some idea on how to do these things. And as always, if you have any questions, feel free to email me. And otherwise, looking forward to receiving your work. Bye-bye.